Water is made of molecules, just like dioxygen, but each one of these molecules is made of two hydrogen atoms bound to a single central oxygen atom. The bond between the hydrogen and the oxygen atoms are covalent bonds, just like in dioxygen. That's our first example of a molecule made of more than two different atoms. Of course, this is a very simple molecule, and there is an infinite number of other molecules that are much larger and complex. And of course, you may have heard that water is a liquid. What does it mean? If you zoom in on a water glass near its surface, you would see something like this. As you can see, the water molecules can move around freely, a bit like in a gas, but they keep contact between each other, a bit like in a solid. Why? Because the water molecules are held together by weaker forces than in solids, but much stronger than in gases. So, in some way, liquids are a kind of intermediate state between solids and gases. It's hard to see those weak forces in this simulation, but you know what? There is another form of water where those forces are much more visible. You know which form? Ice. Of course, ice is a solid, not a liquid anymore. And it's a very special solid, just like salt, it's a crystal. But it looks like much more complex, doesn't it? Move around it, and if you look at it in the right directions, you will see some hexagons. And you know where we find hexagons like this? In snowflakes. It's not a coincidence. In crystals like salt or ice, the atoms are arranged in a very specific way, and the visible shape of the crystal is determined by the way the atoms are arranged. So you can see with your own eyes something that should be impossible to see directly, the way atoms are arranged. So why ice is a crystal? Because the weak forces that hold the water molecules are enough to keep them in place when water is cold enough. When water is at room temperature, each molecule vibrates and tries to move around, the forces are not enough to keep them in place. But when water is cold enough, the molecules have less energy, move with less speed, and the forces are enough to keep them in place in the crystal. In the case of water and some other substances, those weak forces are called hydrogen bonds. The hydrogen atoms are weakly attracted to the oxygen atoms of the other molecules. You can see them. They are displayed with some dashed lines. And of course we still have strong forces inside the molecule, between the hydrogen and the oxygen atoms of the same molecule. So we have two different types of force here, strong covalent forces inside the molecule and weak hydrogen bonds between molecules. Just to finish with water, we have one more form of water to see, steam. It is the gas form of water. When you heat liquid water, you give the molecules more energy, and they move faster. If they move them fast enough, they will be able to escape completely the hydrogen bonds between them, and they will become a gas. Each molecule zooms around, like for dioxygen. Steam is invisible, just like dioxygen, and you can find it in the air around you, just like dioxygen, dihydrogen, and other gas. Sometimes this steam turns back into water droplets, and that's we call clouds. They are made of tiny water droplets floating in the air. So we have seen quite a lot of things. We've seen atoms and molecules, which are the building blocks of chemistry. We have seen that atoms can be arranged in many different ways. They can be single, like in helium. They can form molecules, like in dioxygen. They can form mixtures like in air. They can form solids like in aluminum. They can form crystals like in salt or ice. This is possible thanks to different kinds of bonds. Covalent, metallic, or weak hydrogen bonds. And so we've seen the different forms of water. Solid for ice. Liquid at room temperature. Gas for steam. If you have not understood everything, don't worry, we will see everything in more detail in the next lessons. My goal was just to show you how atoms and molecules can be arranged in very different ways, even in everyday life substances, and the rich variety of chemical substances that we can find in nature. Chemistry a kind of a giant construction game, with some rules that we will see later, but as you can see everything is quite logical, don't worry and enjoy.